Hey everybody, today we're going to be talking about rounding whole numbers. Now sometimes people ask what rounding even really means, and all it means is that we're going to change a number into something that's easier to work with. And you're going to notice rounding happens a lot when you're asked to estimate and also when you're wanting to maybe do some math mentally. In this first example, it asks us to round the number to the underlined place. Now sometimes the question will be asked this way, where they give you a number and one of the places is underlined and you have to round to that place. In other examples, they may ask you to round to a specific place. They won't underline anything, but they may ask you to round to the thousands place or the hundreds place. And we'll deal with that a little bit later on. But in this case, they've given us the number 2,863, and the 8 is the underlined digit, and that's in the hundreds place. Now there are a couple things that can happen to that underlined place or the place that you're rounding to. The digit can go up by 1 or it can stay the same. And those are the only two things that can happen to that underlined digit. Now there are some rounding rules that we use to help us out. And what the rounding rules ask us to do is to look at the digit to the right of the rounding place. And in this case, we see a 6. Now the rounding rules state that if the digit to the right is 5 or higher, then the rounding place itself, that digit will go up by 1. If the digit to the right is 4 or lower, then the rounding place will stay the same. So in this example, you can see that the place to the right of the rounding place is 5 or higher. It's a 6. And because of that, our original underlined place, that 8 in the hundreds place, that's going to go from an 8 up to a 9. And one thing I encourage my students to do is use an arrow to indicate that we've rounded. And when we round properly, 2,863 to the nearest hundred becomes 2,900. A couple things I want you to notice here is our original rounding place was the hundreds. Notice that the place to the left, there's only one of them, that digit stays the same in our final answer. The digits to the right of the original rounding place, they became zeros. So when you round, you will see zeros in your answers quite often. In our next example, it says to round the number to the nearest thousand. So they're giving a specific place to round to, and you'll notice that I underlined the 6 because it's in the thousands place. Now again, the place that we're rounding to, in this case the thousands, only two things can happen. That 6 can become a 7 or it can remain the same. And the way we determine that is to look at the digit to the right of the rounding place. We notice that it's a 5. And the rounding rules say if the digit to the right is 5 or higher, the rounding place digit will go up by 1. And remember, if the digit to the right is 4 or lower, the rounding place digit would stay the same. In this case, we can see that it is 5 or higher, so that means our original place that we're rounding to, the thousands place, has a 6. That 6 is going to round up to a 7. And again, I'm going to use that arrow. 6,541 rounded to the nearest thousand becomes 7,000. And once again, notice that all of the digits that were to the right became zeros in our answer. Again, we're being asked to round to the nearest thousand. And again, the thousands place has a 6 in it. That 6 can become a 7, or you remember, it can stay a 6. The rounding rules tell us to look to the digit in the place to the right. In this case, it's a 3. And since you know that that is 4 or lower, that means our rounding place digit is going to stay the same. So 6,321 rounded to the nearest thousand becomes 6,000. Now in class, we don't have the opportunity to highlight numbers and have them, float up above and fall down below. So one thing that's a very practical strategy to use is circling the place to the right. I always encourage my students to underline the place that you're being asked to round to and then circle the place to the right. And I'll show you what I mean. Again, in this example, we're being asked to round the number to the nearest thousand. You'll notice that I underlined the 5 because it's in the thousands place. I find that it's always very helpful to do that. Now, I circle, and I ask my students to circle the place to the right to really help you focus on that. we can see that that digit is 5 or higher. So that means that our rounding place in the thousands, that digit is going to become a 6. So 65,780, when rounded to the nearest thousand, becomes 66,000. And again, if you circle it, that's a great way just to focus on the place that you're going to use the rounding rules for, and you underline the place that we're rounding to. In our next example, we're being asked to round the number to the nearest thousand. We have 12,051. You can see that the 2 is in the thousands place, so I've underlined it. That again helps me focus on the place that we're rounding to. I will circle the place to the right, and I notice that that digit is clearly 4 or lower, which means that our rounding place digit will stay the same. And when that happens, 12,051 rounds to 12,000. Notice that my rounding place stayed the same. Notice that the digit to the left of the rounding place also stayed the same. And notice that all of the digits to the right of the rounding place are zeros. In our last example, I want you to notice that it doesn't tell us what place to round to. It just says round the number. And when you're told to round, but you're not given a place to round to, the expectation is that you will always round to the greatest place. So in this case, we have a 5-digit number, so that means it goes out to the 10,000ths place. I've underlined the 8, which is the digit in the 10,000ths place, and I will circle the digit that is just to the right of that. Since the 7 is 5 or higher, that means our rounding place is going to go up 1. So 87,468 will round to 90,000. That's it for rounding numbers, folks. I'll see you next time.